Welcome and hello. This is a tutorial video on HEC ResSim, and in this lesson I'm going to be discussing release allocation. This is part of the Reservoir editor. All right, what I have on the screen here is a very simple reservoir network with a couple of reaches and a reservoir here in the middle. I'm going to open the Reservoir editor by clicking on the Reservoir tool or the pointer tool, and then give it a right click, Edit Reservoir Properties. Okay, as you can tell, I've already added some information to this reservoir. What I have connected to the dam are three elements. There's an outlet group called Tower A, an outlet group called Tower B, and an outlet group called Tower C. If I expand those towers, as you can see, each tower has three outlets. There's upper, middle, and lower. And if I click on tower, I can see the total release for each elevation. Next, I'll head over to the Operations tab. And in previous lessons, we talked about creating an operation set and creating zones and the curves associated with those zones. For this video, we're going to click on the Rel Alloc tab, which is short for Release Allocation. Release allocation is the method ResSim uses to allocate the release from the reservoir to its outlet groups and their available outlets. This is a different release than the release rule because not all releases are governed by release rules. All right, so what we have on the screen here is the reservoir and then the three outlet groups labeled Tower A, Tower B, and Tower C. There are three different allocation types, and I'm going to talk about those here. First, we have the balanced allocation, and the balanced allocation is based on weights. So by default, the balance would just be an equal balance of 1, 1, and 1 assigned to the three outlet groups. But if I wanted to modify those weights and send more flow or more release through one of the towers, one of the outlet groups than the others, then I can come over here, click, and click 2 or whatever integer you want to add. So now this says of all the water, 2 units would flow through tower A or release, and then 1 unit would be released through uh, outlet group tower B, and 1 unit would be released through outlet group tower C. And you don't have to make these add up to 1 or anything. It will be computed and normalized using HEC ResSim's internal math. I could say, I could put an 8 here for tower A, and this says 80% of the release should flow through tower A, and then 10% through towers B and C. And remember, these are outlet groups, so there's multiple outlets for each outlet group, as I've defined it over here in the physical tab of the reservoir editor. The second allocation type is sequential. Sequential basically says release all the flow through the top outlet group. And then after that, if there's more water than can possibly be released through the top outlet group, start releasing through the next outlet group, and so on. So if I wanted to make outlet group C as the primary outlet group or group of outlets that would release the water, I would select tower C. It's currently on the bottom. Come over here, click the arrow up button. It moves up to the top. Once it's at the top, I can't click the up button again. And similarly, if I select the lowest priority, or I should say the last outlet group in the sequence on the bottom, I can't click down, but I can reorder them by clicking up and down this way. So I'll leave it at A, B, and C for this sequential allocation type. The last allocation type is stepped. Stepped is a little bit more complicated. It basically gives the reservoir operator a little bit more control, and it's sort of a combination between balanced and sequential. As an example, the user's manual at the end of chapter 10 does a pretty good job explaining an example and showing some math, but I'll do my best to give an example here. This bottom row, as I've typed it, says 100, 0, 0, which means all the water should be released through tower, this is tower A, I believe. Yes, through tower A before any water is released through towers B or C. That's more of the sequential type of allocation. So I'm just going to continue and put 100 on all of those. But if we had more water to release than could possibly be released from tower A, for instance, say we had 1,000 CFS we wanted to release and the water surface elevation was only 1,400, we could only release 400 CFS from tower A, in which case, if we come over to Operations tab, Release Allocation subtab, we could put a 50 and then a 0. And then that would release the rest from Tower B, assuming there's enough capacity in Tower B. And this 50 represents a percent of the release capacity. So if I put 50 and 50 for towers B and C, that doesn't necessarily mean it's the same amount of flow. It means it's 50% of the total capacity of flow through that particular outlet group. I don't want to try to compete with the user's manual and its example because it does a great job, but I'm just going to type in a few more numbers. Let's actually say that's 50 and then 0. All right, well, I probably could have done a better job explaining that. I will in a later lesson, but just know that the stepped method is sort of a combination between balance and sequential. So that was it for this video tutorial. I talked about the release allocation across different outlet groups in a dam if a reservoir rule does not already control that release. There are rule-based allocations, which we'll get to in the next chapter of the user's manual. And although rule-based allocations take precedent, there are usually releases that are not specifically allocated by those rules. And those are the releases that this release allocation feature was intended to manage.